Hi everyone, today we are going to start 10.4, which is used inscribed angles and polygons. And our goal is to use inscribed angles of circles. An inscribed angle. An inscribed angle is an angle that is inside a circle, such as this one right here. Now when you have an inscribed angle, there's going to be an arc that is inside those lines, such as this arc here. That arc is called an intercepted arc. We talked about before a central angle. A central angle is an angle that comes from the center of the circle. So for example here we have a central angle of 60 degrees. Well, if we use the same endpoints as this central angle, we can create an inscribed angle. And here's that inscribed angle. The inscribed angle is going to be half the length of the central angle. So since our central angle was 60, our inscribed angle is going to be 30. And so I wrote that here. The central angles are double the measures of the inscribed angles that enclose the same arc. And we see here that our arc is arc AC. So they both share that arc. Measure of an inscribed angle theorem. So the measure of an inscribed angle is 1/2 the measure of the intercepted arc. So here's my inscribed angle, angle ADB. Here's my arc here, and we know whatever measure that arc is, this inscribed angle is going to be half the measure. Now there are 3 cases for this theorem. Case 1 is that the center C is on a side of the inscribed angle. So if you look here, we see that C is on the angle, on the side of the angle. Case 2, center C is inside the inscribed angle, and we notice here that it's inside this inscribed angle. And case 3 is when the center is on the outside of the inscribed angle. So here's C, and we see that it is not inside or touching the angle. Use inscribed angles. Find the indicated measure in in circle P. So we first want to look at the measure of angle T. So angle T is here, and this is my inscribed angle. If you look at your inscribed angle, we see our intercepted arc, and that arc measure is 48. From our last theorem, we talked about that the inscribed angle is half the measure of the arc. So if my arc is 48 degrees, what's the measure of angle T going to be? Well, the measure of angle T is equal to 1/2 the arc measure, and we know the arc measure is 48. So the measure of angle T then is 24. Now let's look at the measure of arc QT. So if I look at this arc, I notice that my inscribed angle is right here, and the measure of that inscribed angle is 50. So once again, the theorem states that the arc measure is double the inscribed angle. So all I'm going to do to find the measure of arc QT is I'm going to multiply 2 by my inscribed angle, which in this case is 50, and that gives me 100. So my arc measure here is 100 degrees. Next, we're going to find the measure of arc RS. So our arc RS is right here. Now there are 2 inscribed angles that use that arc, but the one that we know the measure of is this angle right here. So if my inscribed angle is 31, what is the measure of arc RS? Well, it's going to be double that measure. So we know that it's going to be 62 degrees. Next, we want to find the measure of angle STR. So STR, I want to figure out what is this measure. Well, if you notice that it intercepts this arc, which was the same thing here. So since this angle is 31, it means that angle STR is also 31. So the measure of angle STR is equal to 31. Why? Because both those angles intercept the same arc. So here's our theorem for that. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. Name two pairs of congruent angles in the figure. So here's our figure. Which answer choice is correct? A, angle JKM is congruent to angle KJL, and angle JLM is congruent to angle KML. B, angle JLM is congruent to angle KJL. Angle JKM is congruent to angle KML. Answer choice C, angle JKM is congruent to angle JLM. Angle KJL is congruent to angle KML. Or D, angle JLM is congruent to angle KJL. Angle JLM is congruent to angle JKM. All right, so looking at our figure, we see that we have this arc here, which is congruent to which intercepts that angle. And this same arc, KL, has this inscribed angle. So that means that angle, which is in purple, KJL, is congruent to the red angle, KML, which is this right here. Now there are some other angles as well. We know that this angle here intercepts this arc, so this angle. And if you look at this same arc, it intercepts this angle right here, which is this answer choice here, that angle JKM is congruent to angle JLM. So our answer is C. Find the measures of the red arcs or angle. All right, so for number one, we are looking for this angle measure here. What we see is that the arc measure is 90. So what would be the measure of angle HGF? Well, it would be half of 90, so it would be 45. Number two, we want to figure out what is the measure of this arc. Well, if you look closely, we see that this angle is 38. So to find the arc measure, we would double 38. So we end up getting that it is 76 degrees. Finally, we want to figure out what is the measure of this angle. Well, we don't know this arc measure. There's nothing there. But what we do notice is that there's another inscribed angle that uses that arc, which is right here. So if this angle is 72, it means that this angle is also 72. Circumscribed circles. Circumscribed circles are just circles that have different shapes inscribed in them. So here is an example of an inscribed triangle. The triangle is inside the circle. And here is an example of an inscribed quadrilateral, where the quadrilateral is inside the circle. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. So if you look here, we see we have a right triangle. So the diameter is the hypotenuse of that triangle. And we know the opposite. If we know that we have a diameter that's the hypotenuse of the triangle, then we know it's a right triangle. Inscribed quadrilaterals. Only certain quadrilaterals can be inscribed in a circle. Quadrilaterals can be inscribed of a circle if and only if their opposite angles are supplementary. So looking at this diagram here, angle D and angle F have to be supplementary, and angle E and angle G would have to be supplementary, meaning that they add up to 180. So that theorem is going to help us with questions like this. So if we wanted to find the value of x and y, we know that these two angles, Q and S, are supplementary, meaning that 80 plus x is equal to 180. And we also know that angle P and angle R are supplementary, meaning that 75 plus y is equal to 180. So what do we get for the values of x and y? Well, by using simple algebra, we find that x is equal to 100 and y is equal to 105. To double check this, just plug those values back in and you better get 180. Here's our next question. Same thing, I know that my opposite angles are supplementary, so that means that they add up to 180. So let's solve for A first. So I have 2A plus 2A is equal to 180. Combine like terms, 4A is equal to 180, and we get that A is equal to 45. Now let's look at 4B and 2B. So 4B plus 2B is equal to 180. Combine your like terms. 6B is equal to 180. And we end up getting that B is equal to 30.